Okay, so section 3.1, we have here a statement is a sentence that is either true or false, but not both at the same time. A statement cannot be true or false at the same time. For example, I'm going to write an example up here. Miami is a city in Florida. Is this a statement? Yes. Is it a true statement? Yes. Okay. Here's another one. 2 plus 2 equals 5. Is this a statement? Yes, but it's a false statement. Okay. Here's another example. Today is Friday. Now, this is a statement, but it can be true or false, but not at the same time. Okay? It's a statement that is sometimes true and sometimes false, but never both true at the same time. We do have a day where today is Friday, one day out of the week, but not today. Another one. Go to the grocery store. Is this a statement? I would say, well, no, but it's more of a command. Go to the grocery store. Turn off the lights. Okay? It's not a statement, it's a command, and that's neither true or false. Okay? Not a statement. Okay? But a command. In Math Excel, is going to ask you, to identify if given a sentence, is it a statement or not? Okay, and being able to recognize that and remember. Okay, others that could be, that's not a statement. I'm looking in your textbook on page 115 where an example is read pages 23 through 57. That's a command. Okay. If I start losing my memory, how will I know? That's the question. It's not a statement. Okay. And it has here some sentences such as commands, questions, and opinions are not statements because they are neither true or not either true or false. Okay. All right. So any questions about statements? All right, so let's look at the next one, negation. The negation of a true statement is a false statement, and the negation of a false statement is a true statement. Okay? And I also have here in my notes that the negation of a statement is another statement that has the opposite truth value. So the key word for negation is going to be opposite. Okay? Something is, the opposite would be is not. Okay, if it was is not, the opposite would be is. Now there's a symbol that we use here to represent not. Okay, and it's a negation symbol. It's the tilde that will be on our keyboard. Just like in algebra, we're going to talk about the symbols a little bit more in the next example, but Just like in algebra where we use x, you see x a lot in algebra when we're solving. Well, when we are using symbols when it comes to logic, we begin with it starts with the letter P, a lowercase letter P. Now, why? I couldn't tell you exactly why it does that, but we're going to be representing statements instead of writing out full sentences every time. We're going to give statements a variable, a letter. P, Q, R, S. It goes in alphabetical order. But let's look at example 1. Form the negation of each statement. Paris is the capital of Spain. What would be the negation? Now, when we say negation, negation of statement P is expressed by writing, and you have this symbol here, not P. Now, we're not going to use the variables just yet, but to represent the negation, either we can say not, use the word not, or we can start off the statement with, it is not true that. So we can write this two ways, the negation. Paris is not the capital of Spain. Or we can say, it is not true that Paris is the capital of Spain. Okay. So here again, keyword, we're saying opposite. So if something is not, then the opposite will be that it is. So as we look at example B, July is not a month, what would be the negation? July is a month. All right. Example 2, it says express each of the following statements symbolically. Let P and Q represent the following statements. Let P represent Paris is the capital of Spain, and Q, July is not a capital of Spain. So here again, like I said, that we're going to be letting variables represent each statement. And in logic, we use P, Q, R, S, and we can keep going. But P, Q, R, S is the most common variables that we use in logic. So when you're representing a negation, you use the tilde symbol, meaning not P, or we can say it is not true that P. Okay, so you're going to see this a lot, meaning opposite. Okay, so it says if P is Paris is the capital of Spain, how would we represent this symbolically? For example, A, Paris is not the capital of Spain. How would we represent that with the symbol? Do we know? We would use the tilde. And because the statement P is the capital of Spain, the tilde means that it is not. All right, so if Q says July is not a month, then how we represent July is a month? Which variable we're using here? The letter Q. So to take the opposite of July is not a month, which is Q, July is a month, we would say not Q. Example 3, express the symbolic statement not Q in words. Let Q represent the following statement. Q, Chicago O'Hare is the world's busiest airport. How will we represent this as a negation? Yes. Yes. Chicago O'Hare is not the world's busiest airport. Okay. Any questions with this? What we're doing so far? All right, so we're going to be talking about qualified statements. Statements that contain the word all, some, and no are called qualified statements. Okay. Now, in qualified, quantified. I'm sorry, quantified. I've been wanting to say qualified all day. Quantified. All, some, and no are called quantified statements. Okay. The word quantity is hidden in there. Okay. And our statement will sometimes have something about a quantity. All poets are writers. Here's some examples. Some people are bigots. No common colds are fatal. Some students do not work hard. Now, this is where you're going to have to, I don't have a catchy phrase or something for you to remember. We're going to be looking at the equivalent statements to what we have here. All are B's. All A's are B's. The equivalent statement is there are no A's that are not B's. Okay, so this is where, yes, we're going to work together with this because it becomes confusing. So all are is the same as there are no that are not. Okay, and this table is one that you're going to have to learn. Some A's or B's. There exists at least one A that is a B. Now we can draw the Venn diagrams with this too. How do you think we can represent some A's or B's with a Venn diagram? Say it again. Some A's are B's. Could they intersect? Some A's or some B's. There exists at least one A that is a B. That's equivalent. Okay. No A's are B's. Something like that. All A's are not B. That will be the equivalent. Okay. So here's some examples where some statements where they are equivalent. No colds are fatal is the same thing as saying all common colds are not fatal. They're not going, and I think about it, they're not going to intersect here. Okay. Some A's are not B's, but we have here the equivalent statement, not all A's are B's. Okay. So, and that some A's are not B's could be the same thing as that some A's are not B's, but not all A's are. So we're going to be looking at how to, okay, write the equivalent statements out here. Okay. Any questions with this? Because you guys are a quiet bunch, very quiet.